Name is Viren.
And my name's David, and we'll be going over the demo for our attack implementation.
All right. To start, we first grab Node.js version 10 using this curl command. This allows us to link LGSVL to RViz.
And then we then installed Node.js version 10 with a simple sudo apt install command.
Next, we moved into the ROS2 web bridge directory. In here, we installed npm, which we had already done previously.
And then next we went to the main directory to update all packages with sudo apt update.
We then downloaded LGSVL messages from GitHub by running a git clone command.
We first removed the original build and built our own.
We then went into that directory and did a colcon build. This is used to build all the packages within the workspace. But we first had to remove the previous build and then build the new one.
And then finally we set the source to install setup.bash.
The next stage of our attack goes as follows. We first opened a new terminal and started ADE within it by using ADE enter.
And then we changed directories to AutoWare Auto.
We previously did a colcon build in this directory, so we did not include in the demo as it took 25 minutes to compile everything.
After building, we set the export path and the source to the directories in the video.
Finally, we started RViz, which allows us to visualize the LiDAR sensors within LGSVL using this script.
After starting RViz, we opened a new terminal window and entered ADE.
We then changed directories to the ROS2 WebBridge folder and set the source to the one listed on the screen.
After this, we ran Node, which allowed us to start a WebSocket server on our local host, which allows for connection between LGSVL and RViz.
After that, within RViz, we changed the fixed frame to LiDAR front, which allows us to view the front LiDAR sensor data from the vehicle in LGSVL.
We then changed the topic under transform points to LiDAR front slash point underscore raw.
Lastly, we started our simulation and verified that all cars were in the SVL simulator. Here you can see us verifying it in the bottom right hand corner.
So we realized that the third car was not in view of the first and second car, so we had to drive the car closer to the other cars.
This
This
part
took some
took,
time
yeah, exactly.
because it's like 1 frames per second.
We were unsure how to get in reverse, so we had to drive pretty carefully the entire time, excluding this off roading. But if we were to hit a building, we'd have to restart because our car wouldn't be able to move in the
Yeah,
reverse direction.
and we restart with F12.
While David was driving, I pulled over, or I pulled up the utilization within Exosphere to verify our RAM did not max out because we faced that issue multiple times previously, which caused our simulation to crash. Here we did not have that issue.
Oh, right now we're just trying to set up the cars next to each other.
All of these vehicles are equipped with LiDAR, and this is our main test vehicle, the vehicle in black. This vehicle's visualization is what shows up in RViz in the next screen.
So after we set up all the cars next to each other, we were able to visualize it in RViz.
And in conclusion, our attack failed because the LiDAR data was transmitting without any problems. We looked around to make sure all LiDAR points were being hit properly, and they were. We thought initially that the LiDAR sensors would scramble the data to our test vehicle, the black car's LiDAR, but were unsuccessful.
So for future directions, we'd like to test more than three vehicles, but there's certain limitations when within like getting more utilization for exosphere resources. This includes getting more cores and more RAM. Um, we upgraded from 2 to 4 cores, then went from 4 cores to 8 cores, and after requesting 16 cores from ORC, we were only able to be given 12 cores. As previously seen in the demo, before our CPU utilization was maxed and our GPU utilization was barely used, which caused a bottleneck.
Thank you for watching our demo. We hope this was informative to you, and have a great rest of your day.
Thank you.